Okay. Hello guys, welcome to my YouTube channel. Today we are going to talk about new calculus, and in new calculus we are going to talk about local model checking. We'll also talk about global model checking, but in next video. In local model checking, what we do is we check whether some state S satisfies mu calculus formula. Some state, not all the states. Okay, let's begin with our example. This is a crypto structure, and these are the states in the crypto structure. This is the question. We have to show that in a crypto structure K, we have a state S naught, and this should satisfy. We have to check whether S naught satisfies this formula. Okay, so what we have to do is first, this is the first step is quite simple. It is S naught, this state which we have to satisfy, and the formula, the formula to which the state has to satisfy. And this one stands for true. This means true, and if it was 0 over here, it would have meant false. Okay, and this one has come from, this is the final result that comes from the bottom up. It's a bottom up technique. We go down, we solve it, and when the answer is true, both sides true, and then we come up and then we put a 1 over here, which means this state satisfies this formula. Okay, so let's begin. This is, I have already solved this example, and we will go and see what happens. Okay, so first case, mu x. Mu is the least fixed point, and according to the rule, these are the local model checking rules. Okay, so as this formula is least fixed point, and what we have seen here is when it's least fixed point formula, forget this and replace it with state and the formula. Forget this mu. Okay, but remember that the variable x is bounded by least fixed point. Just remember it, but forget about this and replace it with this, the state and the formula. So we have replaced mu x, and we have replaced it with the formula, the state and the formula. Okay, now good to go. Now the second step, what we have to do is, it's A or box x. So as it's an OR condition, so we have one of the answer should be correct. S naught and A, we have to check S naught and A, and then we have to check S naught and box x. If one of them is true, the answer will be true. So we can do this. S naught and A, we should choose it wisely in here, because it's an OR, and if we select any one of the, if we solve for any one of the situation, we will get, if we get 1 in the first place, then we don't have to do a long work. Okay, so for, if we check S naught and A in here, S naught is, there is no A in S naught, so it's false. So we won't take S naught and A, we will take S naught and both sides. Okay, so S naught and A is false, and S naught and box x is true. This is just for your, this, I have done this for your understanding, but once you get to know how to solve the problem, you just do it quickly. You don't have to follow this step. Okay, so now in step 2, we have S naught and box x. Now we have to check whether S naught satisfies box x. But before doing this, we have to do this by a rule, S naught and box x. So this is the rule 3. We replace S naught and box x with this S1 in formula 1, and S naught and the other formula, and it's S naught until Sn. So it works like that, this, and there's an and between this. So there's an and, remember this. So what we do is, okay, So in here, what we do is, this is 3. Okay, this is the formula 3. What we do is we replace S0 bots x with S1 x. And remember, bots s is replaced, bots formula is replaced by just formula. So there is no bots x, it's just x. But S1 x, and then we have S3 x. Okay, and there's an and. There's an and. That means that both of them, if both of them are true, then it will be true, else it will be false. Okay, so now what we are going to do is that for x there are 2 cases. For x in the formula we have 2 cases like this in 9. Case 1 is that if x is in the label of s, then we just have to, in the label of the x, it means that if x is in any of the label of the, not anyone, the state that I'm checking, if it's in here, I'm checking s1. If x is in the label of s1, means if x is in here, then it will be true, else false. But if x is a variable bounded by, if x is variable bounded by fixed point, that means that if x is a bounded variable by a fixed point, then we are supposed to replace that x with its formula. Okay, so in here x is not a label, x is not in the label of x. X is a bounded variable, it's a least fixed point bounded variable, so we have to replace x by the whole formula. Okay, I hope I'm clear. It's a little bit difficult, but I hope it's clear. There are the 2 cases. So here the x is a bounded variable. Okay, so x is variable bounded by fixed point, then we replace it by its definition, which is the body formula of that fixed point formula. Okay, so we have replaced x with this. That is the body formula of the least fixed point. Okay, now again, forget about mu x according to the rule 7 that I showed you. According to the rule 7, forget about the mu x, and we are here. Now again, we have to choose quite wisely. If we solve for, we have to solve for S1a, we have to check whether S1 satisfies a, and then whether S1 satisfies bots x. But if one of them is true, then the answer will be true. So as it's quite simpler to solve S1 and a, it's quite simpler if we solve S1 and a, as S1 has an a inside, S1 satisfies a, so we don't have to check for S1 bot sets, because bot sets is a little complicated to solve. We have to put this again, and it will go, so it will go on. So we will solve for S1 and a. S1 and a is true, it means there was an OR condition, it means it's true. So these all are true, so we are true at this point. Now we will check for this. The same goes in here. X is a bounded variable, so we will replace it with the whole formula, and then comes S3a, and then S3 bots x, sorry. So here again, in the OR condition, we have to be really wise, because if one of them is true, the answer will be true. So we should choose the point where we can get the answer quite quick. So S3 has an a inside, so we don't have to check for S3 and bot sets. We already have a true, so S3 and a. So the answer is true. So we get true up here, and so this means that S0 satisfies this formula. I hope, guys, you have understood this. If you have any queries, you can mention in the comment box, and kindly don't forget to subscribe my channel and hit the notification button. Bye.